Welcome to the seminar about satellite-derived bathymetry for national agencies and maritime business development in Indonesia. My name is Thomas Heege. I'm Managing Director of company EOMAP, a company headed in Germany. By education, I'm a physicist and working in the field of aquatic optics and remote sensing since 1903. Since 1906, working at the German Aerospace Center in international collaboration developed since more than 20 years the system for physics-based retrieval of aquatic parameters such as satellite-derived bathymetry. And my company EOMAP is mapping and monitoring aquatic systems worldwide. So we are a high-tech company established 2006 in Germany with affiliations nowadays in Australia and USA and partners in Indonesia and Brazil. We serve to engineering companies, to governments, intergovernmental organizations and academia worldwide. We provide software solutions and online tools, training, and practically we are working in hundreds of mapping projects worldwide, more than 100 projects just in the last 2 years in 25 countries. Satellite-based information. Nowadays we have a lot of satellite imagery. Each year we have more and more satellites in space with different spectral, spatial resolutions and also different sensor types. For Indonesia we have approximately 100,000 satellite records per year nowadays, and that's a huge benefit which can be used for these maritime applications. And I would like to tell you a little bit more what is key here and how can this be used. To use such information you will need software analytics, and satellite-based information are impacted by a lot of environmental factors. You can imagine clouds, sun glitter, sun reflections at the water surface, turbidity when you want to estimate bathymetry. So there are a lot of impacts to be corrected. So the accuracy of such services is very sensitive to the kind of analytics you perform. That's why we invest a lot of effort into this kind of analytics and software tools, and I will talk about this in this presentation as well. And I will of course talk about applications, so where you can use this information and how you can increase safety for maritime navigation, for planning. So there are a lot of aspects how you can use this and how agencies can use this information to support the country, so to support the economic development of the country. For example, satellite-derived bathymetry is used for planning, for surveying, for charting, for monitoring nowadays already. And I will give you some ideas in which kind of projects these are already used and could be used in Indonesia as well. For example, SDB is used for planning in Saudi Arabia. You may have heard about these giga projects to develop new cities in the coastline. Means you need a lot of data for planning. Most crucial is of course in the water, the topography, that means the bathymetry. And here we deliver to these kind of projects bathymetry, in this case also together with land elevation models. Land elevation models, so it means seamless models of the topography from water up to land integrated with steam water, is also a frequent topic. For example, if you need such data for tsunami modeling, for sea state modeling, again also for project development, such data are as well provided greatly by different remote sensing products, bathymetry, land elevation, and then assimilated with third-party data such as the deep water bathymetry data from the hydrographic offices. SDB for planning is used also, for example, in the Eastern Caribbean states. Here, for a huge area, in this case, we use the resolution of 10-meter data covering quite huge data of many islands in the Caribbean state, again supporting planning and economic development in that region. Another aspect is satellite-derived bathymetry and seafloor mapping for environmental directives. For example, last year we mapped the whole Great Barrier Reef, covering several 100,000 square kilometers, with bathymetry data and seafloor information, delivering this information together with the partners in the country to the Great Barrier Reef Agency and Authority. First time that the whole barrier reef is covered with such a high resolution, in this case 10 meter, with this relevant information. Much higher resolutions are as well served. In this project here for the World Bank in the Caribbean areas, it's a combination of very high resolution satellite-derived bathymetry data with drone data in 10 centimeter. So here as well you can control the maritime development and the maritime changes. Another example from Abu Dhabi, benthic habitat mapping. So it is a whole state covered here with benthic habitats derived by satellite combined with ship-based measurements. For maritime industries, there's a lot of applications as well. One example is company Van Oort, who serves in different countries with different dredging activities in order to develop islands and countries and ports. Bathymetry is again here a crucial parameter for planning of these big ships. And the complementary, very complementary, is the sediment monitoring. For example, if you have environmental directive, you want to protect the coast in order to prevent that very high sediment loads might danger than protected zones. That's another application we serve for different companies and port agencies worldwide. So in hydrographic applications, the benefit of the satellite data might be already quite clear. It is non-intrusive. You can receive data at remote and inaccessible areas where otherwise it would be difficult to get data. You have an extensive coverage with these kind of data and spatial and temporal continuity, which means you can even go back in time using satellite records up to 30 years back in time to compare what was there 10 years, 20 years ago. Of course, with lower resolution at these times 20 years ago, but from nowadays on, we have a continuous flow of new data, so very high resolutions. It's very affordable and low cost in comparison to traditional methods when you have to send ships and boats, and it is very complementary to these kind of measurements. You have to care about quality with this kind of information because of the environmental impacts, as I mentioned before. And that's why we have to look for data analysis and the right quality assurance and quality correction procedures. This comes to the topic software. So we provide and train also agencies and countries on software and train on the major understanding of these tools as well. So for bathymetry we have different tools which cover a little bit different needs. For example, WattCore is a fully physics-based software which can be installed locally to work independent even if you don't have any calibration data or in situ data on hand. It's very transparent because of the fully physics-based way. That means you can run this quite simple that it runs through, but you as well can go into each detail in each physical level to compare the outcomes of this software. LightCore is as well implementing physics-based methodology combined with machine learning. The advantage here, it is very rapid and even more easy to use, and but it does require calibration data. And we have this runs as well local, but we have also a version which runs online. That means you just need a web browser. You need nothing to install on your computer. You use the EOMAP cloud computing facilities, which are already connected to the satellite data archives. So this allows you as well to fill gaps, and I will explain this later in detail. And there are further supporting tools which you can use to generate high quality bathymetry. So you saw already we have portals, online portals for different topics, for visualization, for production, and so on. I may come back to this in another webinar. Now I want to give you a taste of the Iolytics SDB, Satellite-Derived Bathymetry tool, very easy and fast tool to fill your data gaps on bathymetry if you have already some data on hand. And you can do such an exercise even within 1 hour. I will give you here one example of an island in front of Jakarta. We kindly received data here, and the first step is that you look for the appropriate satellite scenes. There are hundreds already available for these areas, and we have therefore an online tool which is again already connected to the satellite data archives, which helps you to find the most suitable satellites to process. Because that's crucial to select suitable satellite scenes and not too easy also to identify. This takes you 5 minutes. It's an online tool. You select the area of interest and you get as output a few minutes later those satellite scenes which have the highest quality, and you can use them for the further processing. In this case, we received by the Hydrographic Laboratory ITB in situ data, so transects, which you see here in red. Thank you very much for this. We used just a portion of this data to demonstrate what is the outcome of this online tool and how fast this can be used. So we use the green, you see the green data here, the green area, these kind of transects to upload this to the portal. So it is one step. Another step is to select those scenes which were detected earlier, press start and run this process, which then automatically calibrates these scenes with a mixed physics and machine learning approach. So that means it does a lot of corrections, but at the same it does an appropriate calibration of the data. And after approximate 40 minutes in this case, you already have the data ready for download. These data are delivered in different formats, X, Y, Z, GeoTIFF standards, so all the standards that you can use and further to for your application. In this case, you now have the full area shallow water bathymetry, not only the area covered before in those gaps, but also the surrounding areas, even the surrounding island, which was recorded under similar environmental conditions. And if you compare this with the data which we didn't use for this exercise, you see that the transects here, you see transects 1 and 2 match very well of the survey data to the satellite-derived bathymetry. And here overall we have an error of approximately 50 centimeter plus 10 centimeter depth for almost 90% of the data, which is quite good for such an exercise. And you see as well that you have now data in areas that you didn't have data before. So that's a big advantage of this tool. Just 1 hour time, and you don't even need to download those satellites to your computer. You don't need to install anything, and can rapidly access and fill your data gaps here. There's another software which is even more professional. It's a fully physics-based WATCO-X desktop software, which we also provide. And the benefit here is if you don't have any data on hand, you can use this. It's very transparent. And since end of 2020, now in the testing phase, we have a new version of this program which has even multi-image processing. The big advantage is that with this process we can increase the accuracy of the products, because different image parts always have varying quality in terms of the environmental conditions. If you process several scenes at one time in this physics-based approach, it is clear that you can then increase the accuracy. You see there's a lot to learn. It's not too complicated to use satellite imagery, but there's also things to learn to how to use such tools, how to bring this together with your kind of business or with obligatory work that you have done as national agency. So we train regularly agencies and industries on these aspects. For example, in 2019, training for water quality monitoring here for the 8 state agencies in Germany. In 2019, for 2 countries on the SDB, Satellite-Derived Bathymetry watt solution. As well in Brazil, to use the online platform Eolytics for water quality, to train large companies such as Fugro how to use Eolytics satellite-derived bathymetry. There's even an article about that. And again, beginning this year, before the Corona crisis started, we trained as well another agency, and we will continue this also with online webinars. So you are very welcome to come back to us. EOMAP is located close to Munich in Castle Seefeld. Here we hold trainings as well here in Seefeld. And I very much invite you to stay in touch with us also through our partners in Indonesia, Geotronics, and have a good day. Thank you.